Hello, friends. We are back with episode 219 of the Our Weekly Highlights podcast. And if you're here around in the United States, we wish you all the best if you're digging out of foot or even multiple feet of snow after the recent winter storms here in a lot of the country. We hope you're safe. We hope you're healthy. But we're gonna give you some at least a January cheer here, so to speak, with some great highlights to talk about on this week's Our Weekly issue. My name is Eric Nance, and I'm delighted you joined us, hopefully in between either shoveling or just trying to stay warm. But speaking of staying warm and trying to dig out, my awesome co-host here has done his fair share of shoveling here. Mike Thomas, how are you holding up, my friend?
I'm doing pretty well. I am literally joining you in between snow blowing and shoveling. We got about 2 feet out here in Connecticut, and we are digging out. It's up to our waist.
Yes, I had kids and my wife wishing something like this would have happened around Christmas time. It did not here in this country, so I guess about a month late. I guess beggars can't be choosers in this case. But yeah, hope you all are safe out there. Yeah, my arms are still sore after the shoveling escapade, and my snowblower wouldn't start. So it was all the old-fashioned way, as they say. Nothing old-fashioned about our weekly, though. We have some great highlights to talk about here, and our curator this week is Jonathan Kitt. And as always, he had tremendous help from our fellow Our Weekly team members and contributors like all of you around the world with your poll requests and other suggestions. And we lead off with a bit of a follow-up from a highlight at the end of last year with regards to the use of large language models. Again, big surprise in 2026. But especially when it comes to interpreting visualizations, things aren't always what they seem. And this is a follow-up post on the Posit blog by Sarah Altman and Simon Couch, who, of course, lead their Posit AI blog series, and among many other things they research in the world of LLMs. And this is a follow-up to a post from December, I believe, when they investigated how the frontier models out there, or a handful of them, are interpreting plots based on quote-unquote well-known data, but with a little bit of fudging around the way to make things not actually be realistic compared to what they expect. And they did find that the LLMs could be fooled quite quickly when they think something is already expected, so to speak, on a well-known data set. So they lead off with what happens when they can use a package they developed called Bluff Bench to make, in essence, a different version of the diamonds data set, where the original data shows a increasing relationship between the number of carats versus price, which you would expect. You want the fancy diamond ring, you have to pay up for it. And they changed it in Bluff Bench so that it's actually more of an inverse relationship, that somehow if you increase the carats, the price will go down. We know in the real world that doesn't make any sense. But the models, on the other hand, they would see this new plot, well, see in terms of the way they see it, but because the diamond set is so well known, they still, more often than not, still report a strong positive relationship, even though the actual plot clearly shows it's not there. So what does this really mean when an LLM needs to see a plot? What is this really happening here? So they decided to do a little experiment here and test their hypothesis about, how much difficulty is it to see these plots under different adverse conditions, as they say. So they've done a few different tests here with baseline sets. Again, one looking at the diamond set, but also making very generic column names to not give it any hints. And they looked at how can they interpret these baseline samples that they've done here. You can see a visual in the post where we see a pretty clear linear relationship going from, the increasing, you might say. They do a little box plot of different trends and data, and then a parabolic relationship to see how the LLMs can do well on this very simple baseline set of visuals. In this case, Claude Opus led the way with 92% accuracy. Gemini Pro was shortly behind at 85%, and then GPT-5.2 actually was 100%. So that are two different types of conditions they're looking at here. One is called intuitive and one is called mocked. So in the mocked set, this is where, like what they did with the diamond set, they manipulate the data to be a different plot, but yet it's based on a well-known set. This is where, as opposed to the intuitive condition that they look at, where they do synthetic data that the models do have some expectations about. They give an example of like test scores versus the hours you spend studying as another condition. And in this case, for both the intuitive and the mocked, well, the mocked case, the frontier models don't do very well. In fact, I think GPT was the leader at still around maybe 30-ish% compared to the intuitive case, where they're all doing relatively well, at least relative, so to speak, at around 80-ish% for Claude Opus, down to about 60-ish% for Gemini. Interesting, set of results there, but then they decide, now they've established this baseline where things kind of go haywire. They wanted to try to help the models a bit with some interventions. There are a few techniques they applied here. One was called the memo prompt technique, which is interesting, where they literally told the model to write it a memo with tags literally called memo to help them describe these visual elements of the plot as if they're looking at it for the first time. So then, after they record this, they can look at the final interpretation and seeing if that's consistent. The other way was in the case of Claude Opus, enabling what's called extended thinking, which is a feature, but you have to set a budget for this on tokens, otherwise that might go up the rails. They did 2,000 in this case. And then lastly, called model in the middle, where in essence they've deployed a custom agent model in the process that had no access to the conversation history of the original model to help it describe the plot, but ignoring information such as axis labels. And then this description, this agnostic description from this sub-agent, would then be available to the original model agent to then help it with its interpretation. So definitely the memo and thinking, techniques here did help with the intuitive case. In fact, the memo prompt seemed to give the best, increase in performance to around 92%, which is, again, something that is promising here. And they did notice that model in the middle approach was not that good, but that the actual plot interpretations from that sub-agent were actually pretty good because, again, it was instructed to ignore some of the information like axis labels and whatnot to focus solely on what that plot relationship, that visual pattern was actually depicting. What was interesting is that the primary model sometimes doubted or even ignored what that model in the middle was telling it. That's a head scratcher right there. So that's an interesting result there that they found. And in terms of wrapping this up and what they've seen, what's the end goal of all this? It isn't just to do experiments for the sake of experiments. Posit has a vested interest in how LLMs interpret visualizations, especially in light of their DataBot, plugin, to let data analysts use DataBot on a set of data to start, high-level exploring the different trends in the data, get some initial summary statistics, maybe a report, a visualization, and being able to have an LLM interpret this clearly, at least within reason, is a very important thing for this. So they're actually not quite done with this yet. They still want to look at other solutions, but their big takeaway is that this isn't so much a vision problem, as they say, with the LLMs and whether they can actually see the actual plot. It's about what it thinks should be there, the belief in the data based on preconceived trained data, whatever have you. In the case of Diamond Set, it's fully expecting that increasing cost and carrot relationship versus other cases where maybe they know some things about things like sale prices or test scores or whatnot. It's trying to get the LLM to really look at what it has in front of it and not be solely based on what it thinks should happen. So this will be interesting to see where this takes them in 2026. Again, great experiments that you can replicate yourself because the Bluff Bench package is available on GitHub. But it definitely makes you think a little bit, and at the minimum, definitely watch what any LLM is saying about a visualization, because there are chances it could get it wildly wrong depending on what it thinks should happen. So again, interesting post with a lot of great visuals and quantifications here. So yeah, makes me think twice about feeding that plot into Gemini or Claude anytime soon. What do you think, Mike?
Yeah, obviously, pictures I think are not going to lead to results as accurate as pure text in these LLM use cases with these frontier models, and it's something that I've started introducing into my daily work, working with some of these LLMs. I've had really great experiences doing things like providing a picture of a formula and having it write the LaTeX code for me.
Nice.
That's a free tip out there in case anybody is authoring scientific publications that need to make sure that they are writing their LaTeX correctly, which can be a tricky exercise sometimes, but I'll digress. And maybe these LLMs would have performed better if we spruced up these plots with some better theming. I feel like Nicole Rennie could have helped there. You're right, Eric, that our package Bluff Bench gets used. It's not one I had heard of before this blog post. I imagine that it was probably developed almost exactly for the purpose of this type of evaluation. But I think at a high level, a lot of what is going on here is trying to figure out where these LLMs do well and where they fall short, and maybe more specifically where the LLM's biases are at play. Doing a little bit of reverse engineering to the extent that we can with these black box models. And the conclusion here that LLMs do a great job at interpreting plots that don't contradict prior expectations, it's sort of antithetical to the spirit of science, though. We try not to bring our own prior biases, unless we're Bayesians, and let the data speak for itself, and only then draw conclusions from it. Cassie Kizkarov, I don't know if you've heard of her. She used to work at Google. She does a great job on this topic of thinking about ensuring that you're not bringing any of your own biases to the table when you are doing data analysis. So I think this is a great exercise. It seems like perhaps there's more to come. And, besides anything else, it's important that when you are using these LLMs to understand that they're heavily biased on the data that they were trained on, and ensure that you are taking their output with a grain of salt.
Yes, we've used a lot of salt lately on the roads, but I digress. You walked me into that one. But nonetheless, I think reading this post, there are some really interesting techniques here that even if they're not quite getting to where they want to in terms of these effective interpretations of the plots, maybe these techniques can be used in other places too. I'm especially intrigued by that model in the middle technique of this custom agent that's trying to be, as you correctly stated, as unbiased as possible when looking at these visualizations and really trying to let the relationship stand on its own and figuring out how to use these things effectively. It reminds me of things we've covered in last year's highlights, where having multiple agents, but each agent being hyper-focused on one task and doing it really well is often better than having one agent trying to do it all at once. So I think we're seeing a lot of these kind of patterns emerge here, which I'm trying to take note of and again, very early in my journey of using these and more than just a debugging exercise. But I definitely learn a thing or two here, and it'll be interesting to see the evolution of tools like DataBot and others as more findings, happen in terms of finding solutions to these issues. But it definitely underscores the importance of don't just take everything at face value right away. Definitely have an exhaustive look at that, especially if you're in a regulated industry. There are lots of safeguards that are trying to be put out there about the use of these. But I think this is some promising investigation, and to try to be as objective as possible and not just hand waving it is always welcome to see in this space. And no, these LLMs cannot do everything, contrary to what you might see on some LinkedIn posts from time to time. But I digress.
Sure. And I think maybe one last point, man, yelling at cloud, which, I am pretty often, is, I think sometimes you have to think about the cost benefit of, is wrestling this LLM through prompt engineering and model in the middle or whatever, going to be a time savings for me compared to just writing the code yourself and maybe looking at the output and doing it the old-fashioned way.
Next, speaking of doing things kind of the more traditional way. Yes, whenever we were in our undergrad courses in statistics or data science, depending on which program you go into, it's always more resonating to students when you're able to work with data that is very relatable and seems very current. Not always the coin flips, not always the roll of the dice if you were in the old statistics programs of yesteryear. Well, in this next highlight, we talk about how a certain department not only leverages novel data, but often get into the field themselves to generate it. So this post is coming to us from the British Ecological Society blog, and in particular from Naupuka Zimmerman and John Zobitz. They are both faculty at undergraduate institutions where it's as they say, a blend of, teaching and research, but probably more emphasis on the teaching side of thing. And they always are looking for ways to engage with the students with novel data sets that are related to their overall mission and maybe a domain-specific problem. And that's where there is a very rich set of data coming from the National Ecological Observatory Network, or NEON for short. And these data sets coming from NEON give you all sorts of ways to tackle these different questions from ecology and with empirical data. And this has been around since, I believe, 2014 to actually collect this data routinely from around the world and make these publicly available for research and to catalog this for investigating environment data issues. And in fact, one of the things they can look at that they've done a lot of research in is the changes in soil carbon levels across different ecosystems within different environments. And this is, again, quantitatively measured. And that's not just done, for free, so to speak. It actually takes people to do that. But as these faculty are teaching data science and statistics, what is a great way to get these data into the hands of students to do their analyses? And guess what? We're talking about R, right? Make a package for it. That's exactly what they have done. And there is a package out there called Neon Soil Flux, an R package for continuous sensor-based estimation of soil carbon and fluxes. And this is using not just data that's publicly available, but it's also data that's been collected straight from the field itself. And this has been funded by the National Science Foundation from back, I believe, in 2017. So there's been a lot of work done on this. And the package has different levels inside it that definitely mimic what we might see in the famous pictorial in the R for Data Science book about the life cycle of a data analysis. You need to first get your data in a tidy way, and then to be able to, massage that into, like I said, that tidy fashion, and then expose analytical methods on top of this. So that's where they've built some R code with the analytics side of it, which have some foundational code that applied a technique called fixed law to compute soil fluxes from neon sensor data. That sounds fascinating. So again, the task was to take that type of code, put it into the R package, and having these single purpose functions that do different things, such as converting units and other, helpers for the analytical side of it. And then the packages also had a purpose to help validate these predictions that are coming from these sensors against the actual levels of these, carbon levels coming from the soil itself. And that required actually getting into the field literally. I believe they mentioned 6 core neon sites in the western and Midwest of the U.S., which had many, many visits apparently, and lots of equipment that they had to take to these different sites. There's some fascinating pictures showing the students and the faculty doing this literally on the site. This would be fun to do. And then they basically use that collected data to help do some visualizations of these different types of sensors, or I should say different types of materials and the different carbon levels inside across time, the soil fluxes as they call it. So this is really interesting, taking on, a very real scientific issue, and then letting the students not just build the code to make this, available to the rest of the R community, but to also be able to literally validate the findings with data they actually collect in the field. What a great way to learn. So this package is both on GitHub and on CRAN, and they also have a dedicated research article we'll put to in the show notes with an open access license. That's always great to see. I could go on another rant about paywalls and everything in front of research. This looks like a great use case of literally generating your own data and then putting a nice R package in front of it straight from the field. That would have been a great way to learn statistics in a fun nature setting, if I do say so myself. What did you think, Mike?
Yeah, I was using R in college for the first time for whiteboard mathematical theory, and it did not stick the first time I learned R. This is going to be confession time with Mike. But if any of these students were new to R, what an awesome way to learn a programming language. I can't think of anything more applied than what this blog post walks through. And as you mentioned, Eric, soil carbon flux, which this flux is the thing that they're measuring, is defined as the movement of CO2 from the soil to the atmosphere. And that R package that they created had sort of 3 modules to it, the way that they thought about it. As you mentioned, a data acquisition step, which was kind of that first step, interacting with this NEON API, NEON being National Ecological Observatory Network, to actually get the data, then cleaning it up, as you mentioned. And the last part was calculating these estimated fluxes. And one design choice that they made during development was that sort of a blanket approach to modeling these estimated fluxes just didn't work for every site. So they actually built the package in such a way that they sort of leave it up to the user to decide on the mathematical or computational approach that they want for the estimate that they're trying to make. So that this package doesn't return just a single flux estimate. It actually calculates a suite of estimates that allows the users to select specific sensor depths for their estimation, choose different methods for estimating soil diffusivity, and aggregate those results to create an ensemble estimate, if you will. So I think that's a really interesting design choice for that package. It certainly empowers the user or the researcher to decide which model is most appropriate for their specific ecological site. And as you mentioned, Eric, them actually going out into the field and doing this real world validation, if you will, across these 6 sites in the Western and Midwestern U.S. is just fantastic. And the fact that they've really open sourced everything around this project is awesome, and a phenomenal use case that I hope others in academia see and try to mimic this model.
Yeah, and it's really interesting when we talk about like validating between what we actually see objectively in our measurements in the field versus what these maybe sensors or other technology are predicting. It'd be, in the perfect world, everything agrees, right? But actually, they mentioned in this post that it was actually most interesting when the 2 forms of the data did not agree. And then that's when they start to see what is causing this, and the fact that, there may be different trade-offs of how deep these sensors go and how they might need some, flexibility depending on the type of environment, area they're measuring. But that's another case where often data, when things aren't working as expected, lead to other issues that illuminate, improvements in the process in general. So it does sound like there was a lot of learning to be had, and it wasn't just on the stats side of it. It's about this data collection and the relationship between, automated fashions or sensors and what we're actually seeing with the tried and true method. So I love the collaborative aspect of this. I would have been all over this as a project had it been available to me. So yeah, these students are definitely learning a lot of great life skills that will definitely, hopefully, empower them to successful careers in the world of data science and whatnot. So really great picks in here, especially if you like seeing what happens in nature. And definitely we'll have a link to the research article in the show notes as well if you want to get into the real nuts and bolts of all the methodology. Rounding out our highlights today, you know me, I have the need for speed in my computations, and there are lots of great ways in the R community to make things run faster. And there's a whole gamut of packages in this space. There has been one, I would say, ecosystem in and of itself that transformed so many ways of doing high performance computing across multiple frameworks. And that is what has often been called the futureverse suite of packages, headed by Henrik Benson. And he has just wowed us once again with a new package that's entering this ecosystem called futurize. And what does futurize offer you? Let me tell you, because it is one really, really nice feature. Let's say you've done that traditional lapply loop to loop through a list of things, and it's taken a while. You want to parallelize it, but you just want to do it quickly. You don't have to write a whole bunch of code for this. With futurize, here's what you do. You take your lapply call, you pipe it into the function futurize. That's it. Yes, this is real, folks. Because this doesn't just work with the lapply suite of functions. This can work with your favorite functions from Perl, like map, or pmap, map2, even the for each package of yesteryear that I used many, many years ago. All of this, you do the call, pipe it into futurize, and futurize takes care of the rest. Yes, this does sound like magic. How is this magic actually being performed? That is where this futurize function actually has a purpose, and he calls it a transpiler, transpilation. This is taking the source code that was being piped into it, in this case, the lapply type call, and then transform it from that existing form to another form that would capture what was the original expression, but don't actually evaluate it yet, do the conversion to the parallel type of equivalent, and then execute that converted function. But all of this is behind the scenes. The user doesn't see this. All they see is they pipe it into futurize, and then suddenly the future ecosystem is being used with the appropriate future function behind the scenes. So from the future package itself, they have a function called future lapply. That's what's actually going to be called behind the scenes. Futurize is just letting the user get to that without writing it themselves. This could be absolutely massive. But wait, there's more, because there are certain packages that kind of do their own take on parallelism, in a domain-specific way. Let's look at packages like Caret from Max Kuhn, the boot package, LME4, etc. They may have their own, like I said, built-in ways of doing parallelism, Well, futurize works with them too. So in the case of boot, the example here in the blog post, you run that boot function to do your bootstrapping, and then you feed it into futurize, and it works the way that the boot package would expect it to work, but with future powering it. Same with cross-validation with Carrot. Do the training, pump that into futurize. You're done. Oh, goodness, this seems amazing. So I can't wait to play with this. It is on CRAN now. So if you've been, watching, say, the futureverse or these other parallelism type of packages, and you just want to do something really quick, maybe you're under a tight deadline or something, futurize, I think, is a huge, huge step in the direction of bringing parallelism, bringing HPC to the masses, and it is a very welcome addition to the futureverse, if I dare say so myself.
This is definitely super exciting. I do have a question, though. Are there really people out there still using plier, not dplier? Did I say that out loud?
Apparently so, because he calls it out here.
It works with plier if you're still using plier.
Yes.
That's like, ggplot, right? Instead of ggplot.
Oh, yeah.
Too. I imagine there's some code laying around there. When Henrik talks about, as you mentioned, Eric, under this domain-specific skills section, he lists a lot of machine learning packages that this can be applied to, like Carrot. And I wonder if there's a path to making this harmonized maybe with all or most of tidy models for parallel computing, during computationally intensive tasks like hyperparameter tuning, cross-validation, maybe in a way that's new or better than current tooling. I'm not sure exactly what exists for parallel computing in tidy models right now across some of those activities, but I know when I was using tidy models maybe a year or two ago, most recently, I certainly struggled in some areas with things taking a while to converge on large data sets and some of those hyperparameter tuning tasks. So it'd be interesting to see if there's a way to sort of blanket put this into tidy models. I think that tidy models under the hood reaches out to all these different individual frameworks depending on the type of model that you're trying to fit.
Yeah, I would definitely look into that as well. But that would be, again, a huge win to the tidy models ecosystem if futurize could work nicely there. I definitely see that.
Sure. And then I don't know if this, we've talked a lot about this space a little bit. I feel like we've made some pretty giant advancements here in parallel computing and asynchronous computing with Mirai, right, in the last year or two. So our code and our scripts are getting faster and faster. So Python, you better watch out, because I think that's the only leg you had up on us originally in the old language war days. And I think we're coming for you.
Yep, better get that rear view mirror looked at, because we are driving into that speedy car now to get closer here. But no, this is, oh my goodness. There were times where I was so struggling with trying to get things done more quickly and not utilizing resources responsibly. But things like Future, things like Mirai are going to give you those ways of using these resources, great abstractions to get what you need done quickly. And futurize, the potential of this is absolutely massive. And how this is all pulled off, I want to look in the source code of this, because transpilation, I've probably seen this maybe in action once or twice, but I never actually tried it myself. The idea of taking that source code, you don't evaluate it yet, you just parse it, and then you do something magically behind the scenes to get it into a different form, but the user doesn't have to write that different form themselves. That is a really important technique. I mean, definitely the development muscles are flexing strong with this. So I'm looking to dive into the source code here, and yes, the futureverse is alive and kicking and going on strong. So kudos to Henrik for making this ecosystem so fantastic. And I know in the field of research, this is talked about quite a bit. And I would have used the heck out of all this in grad school had it been around back when I was doing my dissertation simulations, by just literally connecting to 5 different Linux servers via SSH and manually launching them like a caveman. We didn't have much back then, folks. What can I say?
Dating yourself a little bit, Eric.
A little bit. Try a lot. I'm used to that here. But there's a lot here in this issue to, not date yourself with, but to keep on the cutting edge, folks, because y'all in the R community now, well, you got a lot at your disposal here. So with that, there are a lot of other things that we won't be able to talk about too much in this issue, although I will call out one thing before we get to our feedback. It's always fun when what we are doing here at our Weekly actually spurs on some learning of from using our actual podcast. And that is where I'll shout out. I'll put a link to this in the show notes. Nils Inditrin has built an Our Weekly Highlights podcast assistant, an AI-powered chatbot that has taken the transcripts of selected episodes from this very podcast and used our podcasting hosting platform, Podhome, which again, shout out to Barry at Podhome. We're doing great with you, to get the transcripts, scrape them directly, and to be able to then use the API, because there's an API with that service too, and built a custom RAG, which we talked about, a couple episodes ago, about a great way to get started with RAG and R. Well, this is literally doing that with our own transcripts. It's got the whole gamut of how he pulled this off. And yes, there is a Shiny app that's powered by Shiny Chat to give you this custom bot to search our transcripts of real language. Oh my goodness, this is awesome. So we are super appreciative of this, Nils, and keep it coming. We love showcasing this stuff, and we're happy that our little banter here can be a source of knowledge, hopefully useful knowledge.
Yes. Oh my goodness. I am, I guess, glad that you edit out the pre-show and the post-show, Eric. Couldn't imagine if Rag had access to that. But this is super, super cool. I appreciate all the work that Niles did on this project. And the Shiny app is absolutely awesome. Great demonstration of some of the latest and greatest from the R Posit ecosystem here. And one of my favorite things about the Shiny app, and something that we try to do as well in similar apps like this, is provide some example prompts that sort of allow you to get started and get your mind thinking about the different things that you could ask this tool. So I've been playing with it here for the last couple of minutes, and it is fantastic. Really, really cool.
Awesome. And apparently, Mike, we got some feedback to the show too. You want to take us through that?
Sure. Yeah, I just wanted to quickly say a thanks to Angelo D'Ambrosio for the message on Blue Sky this past week, I think regarding Nicola Rennie's post. And I hope we were able to point you in the direction of some examples of data visualizations and plots that have the takeaway in the title, which is one of my favorite tricks. So thank you for the engagement there. Great to hear from you.
Yeah, absolutely. And that's a technique I'll be using a lot more of in my custom visualizations. In fact, we have a Shiny app at the day job where we're letting the user download a Quartal slide with the plot, but with annotations. And we're going to use these best practices in that downloadable feature. As Mike said, the good thing I don't put in the pre and post show, because I have about a huge rant I will probably do in post about that, but I'll save that for Mike and I exclusively. But what you all get to hear about is, of course, the Our Weekly itself, which, again, it's a community project, folks. All the resources are online. No paywalls in front of this. You can find the current issue at ourweekly.org, as well as the back catalog, and that goes for the podcast as well. We're linked directly on ourweekly.org. Again, generous hosting provided by Podhome. Thank you, Podhome, for helping us out. And, of course, we've got other ways you can get in touch with us on these social medias. You can find me at our podcast at bsky.social on Blue Sky. You can also find me on Mastodon with at our podcast at podcastindex.social. And I'm on LinkedIn. You can search my name and you'll find me there posting about this very show, or who knows what else is happening in my sector. And Mike, where can the listeners find you?
You can find me on Blue Sky at mike-thomas.bsky.social, or you can find me on LinkedIn if you search Ketchbrook Analytics, Ketchbrook. You can see what I'm up to.
Yes, and I dare say that's always in all my in our transcripts now. So the LM shouldn't have any problem knowing where Mike is. They're available to be found. Hopefully so, anyway. But with that, we're going to skedaddle on out of here with our respective clearing out of snow and or clearing out our code bases. Probably both sometimes are arduous tasks for different reasons. Nonetheless, we're going to close up shop for episode 219 of our Weekly Highlights. We thank you so much for joining us, and we will see you back for another episode of our Weekly Highlights next week.